Ever wondered how pilots know their altitude while soaring through the skies? The answer is the altimeter. An altimeter is an essential flight instrument nestled in the cockpit of every aircraft, from the smallest gliders to the largest commercial jets. It's a bit like a mountain climber's best friend, providing crucial information about how high the aircraft is flying. Now, why is that so important, you might ask? Well, knowing one's altitude is critical for navigation, maintaining safe flight levels, and avoiding obstacles such as mountains or other aircraft. It's akin to a driver knowing their speed on the highway. Too low or too high, and things can get risky. In essence, an altimeter is a sensitive barometer that measures the pressure of the surrounding air to determine the aircraft's altitude. So, an altimeter is a flight instrument that measures the aircraft's altitude. But how does it do it? So how does this crucial instrument measure altitude? It's all about air pressure. Picture a balloon filled with air. As the balloon ascends, the air inside expands due to decreasing atmospheric pressure. This principle is exactly how an altimeter works. But instead of measuring expanding air in a balloon, an altimeter is finely tuned to measure the changing air pressure around an aircraft as it ascends or descends. Atmospheric pressure, also called barometric pressure, is the force exerted by air weight in the atmosphere. Here's a fascinating fact. At sea level, the average atmospheric pressure is approximately 14.7 pounds per square inch. That's like having a small bowling ball pressing down on every square inch of your body. As we ascend, the atmospheric pressure decreases. This decrease isn't linear, but it's predictable. For every 1,000 feet of height gained, the pressure decreases by about 1 inch of mercury on a standard day. Altimeters are designed to convert this change in air pressure into a measure of altitude, displaying the aircraft's height above sea level in feet. Now let's talk about types of altimeters. The most common type found in aircraft is the barometric altimeter. This type of altimeter uses a set of aneroid wafers that expand and contract with changes in air pressure. The movement of these wafers is mechanically linked to the altimeter's needles, which show the pilot the aircraft's altitude. Another type of altimeter, the radar altimeter, uses radio waves to determine the distance between the aircraft and the ground directly below. This type of altimeter provides an absolute measure of height above the ground, which can be especially useful when flying over terrain with significant elevation changes. In essence, an altimeter is a sophisticated barometer. However, there's much more to it than that. It's a crucial tool for maintaining safe flight operations, ensuring that pilots know their exact height above the ground and above sea level. In our next section, we'll delve into the inner workings of an altimeter. Stay tuned. Let's delve into the inner workings of an altimeter. The heart of the altimeter is the aneroid capsule, a sealed, flexible container that expands and contracts with changes in atmospheric pressure. This aneroid capsule is extremely sensitive to even minute changes in pressure. Attached to the aneroid capsule is the mechanical linkage, which translates the expansions and contractions of the capsule into rotational movement. This movement is then transferred to the dial, a calibrated scale that provides the altitude reading. The dial, the face of the altimeter, is where the magic happens. It's where the complex mechanical movements are translated into a simple, easy-to-read format. The dial is divided into 3 concentric circles, each indicating different units of altitude: feet, hundreds of feet, and thousands of feet. The beauty of the altimeter lies in the harmony of these components, working together to give us a vital piece of information: our altitude. Now that we know what's inside an altimeter, let's see how we can adjust it. For accurate altitude readings, altimeters need to be adjusted to the local atmospheric pressure. In the world of aviation, this process is known as setting the barometric reference. But what does that mean, you might ask? Well, simply put, the barometric reference is the measure of atmospheric pressure at sea level. This reference is crucial as the altimeter works by comparing the pressure at your current altitude to the pressure at sea level. Now imagine you're a pilot preparing for takeoff. You're in the cockpit, running through your pre-flight checks. One of your tasks is to adjust your altimeter to match the local atmospheric pressure. This is done using the Colesman window, a small adjustable dial on the altimeter. The Colesman window allows pilots to manually input the current barometric pressure, which is usually provided by the local weather station or air traffic control. Once this value is set, the altimeter is calibrated and ready to provide altitude readings based on the local atmospheric conditions. It's important to note that the barometric reference can change due to weather conditions, or if you're flying to a destination with a different atmospheric pressure. In such cases, the pilot must adjust the altimeter en route to maintain accurate readings. So the next time you're soaring through the skies, remember, it's not just about reaching new heights. It's about knowing precisely how high you are. So with the correct barometric reference, the altimeter can provide accurate altitude readings. But is it always accurate? Like any instrument, altimeters are not immune to errors. Let's delve into the main sources of altimeter errors, shall we? There are three primary culprits: changes in temperature and pressure, mechanical issues, and of course, human error. Firstly, temperature and pressure changes. Altimeters operate based on standard atmospheric conditions. When the actual atmospheric conditions differ from these standards, it results in errors. For instance, if the temperature is colder than the standard atmosphere, your altimeter will read higher than your actual altitude. Conversely, if the temperature is warmer, it will read lower. Similarly, changes in atmospheric pressure also affect the altimeter readings. A drop in pressure will make the altimeter read higher, while an increase will make it read lower. Next up, mechanical issues. Like any piece of machinery, altimeters can face mechanical failures. Wear and tear, improper calibration, or damage can cause the instrument to malfunction, leading to inaccurate readings. Regular maintenance and calibration are essential to keep the altimeter in prime working condition. Last but certainly not least, human error. Pilots need to adjust the altimeter to the current barometric pressure before each flight. If this adjustment is not made or is done incorrectly, it can result in significant errors. Human error also comes into play when interpreting the altimeter readings. Misreading or misunderstanding the readings can have dangerous consequences. So how do these errors affect flight safety? Well, altitude is a critical parameter in aviation. Pilots rely heavily on their altimeters to maintain a safe distance from the ground, other aircraft, and obstacles. Inaccurate altimeter readings can lead to altitude deviations, which, in the worst-case scenario, can result in collisions or crashes. Despite these potential errors, it's important to remember that altimeters remain a crucial tool for pilots to navigate the skies safely. They are extensively tested, calibrated, and maintained to ensure their reliability. Furthermore, pilots are trained to understand the limitations of altimeters and to consider other factors such as weather conditions and visual cues while flying. So, while it's true that altimeters can err, it's also true that these errors can be mitigated through regular maintenance, careful calibration, and sound pilot judgment. In the hands of a well-trained pilot, an altimeter is a trusted ally, guiding them safely through the vast and sometimes unforgiving skies. Despite these potential errors, altimeters remain a crucial tool for pilots to navigate the skies safely. So, we've taken a deep dive into the world of altimeters. We've journeyed through the intricacies of this essential aviation instrument, exploring its purpose and functionality. We've learned that an altimeter is a device that measures altitude by interpreting changes in atmospheric pressure. We've looked under the hood, so to speak, revealing the complex internal workings of this device and how it cleverly uses barometric reference to deliver accurate readings. We've also touched on the importance of adjusting this reference to account for fluctuations in weather and location. We've even ventured into the realm of accuracy and potential errors, understanding that, like any instrument, an altimeter is not immune to occasional inaccuracies. These can be mitigated, however, through careful calibration and vigilant maintenance. Next time you're in a plane, you'll know how the pilot knows how high you're flying. Until next time, keep exploring the fascinating world of aviation.